So in this lesson, we will focus our attention on linear first order differential equation. Okay, we have two goals. So at the end of this lesson, you'll be able to solve first order linear differential equation by using integrating factor and probably solve application problem related to first order linear differential equation. So maybe we'll keep this application part later, okay, in the next lesson. So we'll focus our attention on the first goal in this part. So first of all, what is linear first order differential equation? So the differential equation which is in this form is called the um, linear first order. That is the standard form of linear first order differential equation. It means dy over dx plus p, which is a function of x, and y equals q, which is a function of x. It can be constant, it can be number, doesn't matter, but any equation in this form, that is the standard form of linear first order differential equation. So how do we do that? Notice that in this case, let's look at example 1. Example 1, part A. Now, dy over dx plus 5y equals e to the 2x. Notice that it's not easy to separate y dy and x dx in a different side of the equation. Okay? In the previous section, it was pretty easy. I mean, we were easily separate x dx one side and y dy another side of the equation. But in this case, it's not that easy. Okay? X and y have such a relationship that they don't want to get separated. Okay, they want to stay together, and that's fine. We have a different technique to solve this differential equation. How do we do that? We're gonna follow 5 or 6 steps. Step 1. Again, one thing please keep in mind. The first questions you'll ask is, can we separate y dy one side, x dx to the other side? If that is the case, then I suggest do that first. If that cannot be done, then think about, is the equation is in linear first order differential equation? Is the equation is this linear first order differential equation? Yes, it is. And what is the standard form? This is the standard form. Now you compare this two. And when you compare this two, what you get, what is the value of P? You know that value of P is 5. If you compare this, dy over dx, P of x is 5, and y is y, and q of x is e to the 2x. All we need to know is what is P. Okay? We don't care about the other values. We just need that. And then what we need to do is step 1, put the equation in linear form. That's what we did. Now find the integrating factor. So integrating factor, write IF, okay, integrating factor, or you can simply write I, it doesn't matter, just you can simply write I. And the formula is given here. You need to memorize this formula, guys, okay? I equals, or you can say I of x is given by e raised to power integration p of x dx. So that's the formula. So our integrating factor is going to be e raised to power integration p is 5 dx. So which means e to the 5x. Don't write c here, because if you write c, you're making your life difficult. At the end of the day, we're going to put c. Okay, once we are almost done with the solving the equation, then we just put c at the end. So I suggest don't put c there. Don't put the constant there. Now, step 2 is done. We found the integrating factor. Step 3, multiply each term of the equation in step 1 by I of x. So remember, this is your equation, okay? Equation 1. Multiply both sides of equation 1 by integrating factor, which is e to the 5x. Let us multiply that. So we're going to get e to the 5x dy over dx plus e to the 5x 5y equals e to the 5x e to the 2x. Okay, I multiply both sides of the equation 1 by e to the 5x. Now let us pause for a minute. Now I want to take you to calculus 1, and I want you to find the derivative of, okay, let me do it here. I want you to find the derivative of e to the 5x and y. Okay, find the derivative of this, guys. So the derivative is, remember, this is a formula, you know, this is u and this is v. It's a product rule. So we're going to use product rule. So if you use the product rule, what do you get? The formula is u dv over dx plus v du over dx. That's the formula, right? Everybody know? Product rule of derivative. We're talking about derivative here. And so u means e to the 5x, dv means y over dx, dy over dx, plus copy v, which is y, and du over dx. So that means derivative of d over dx of u is e to the 5x. What is that? Everybody know that the derivative of this, it will be 5 e to the 5x, right? Or you can write this as e to the 5x dy over dx plus 5y e to the 5x. So what it means is, listen very carefully, okay? What it means is, I can replace this by this. They are equal. They are mathematically equal, you see? I can substitute this value for that, or I can substitute this value for that. So they are equal. Now let's observe this left hand side. Can you see the left hand side is exactly the same thing? Is that correct? Are they equal? E to the 5x dy over dx and 5y e to the 5x. Yes, they are exactly the same. So I can write the left hand side equals d over dx of e to the 5x times y. I can write the whole thing, you know, there are two terms on the left hand side. I can simply replace that by that. Equals e to the, when you add them, you're going to get 7x. Any questions so far? Now, this is what we got. One thing very important, notice that what is this is basically whatever we have there and y. Okay, it is a product of integrating factor and y, and it always works, guys. Okay, it always works. What works? Well, this is your integrating factor times y. Always works. Derivative of integrating factor times y. From next question, I will not do the derivative part. Maybe we'll do one more just to see whether it works for all the problem, but trust me, it always works. Okay. So then now we need to solve this. In order for that, let's go back. We are done up to step 4. We are done up to step 4. Now step 5, integrate both sides. Okay, let us integrate because we don't want the derivative, we just want the value of y. So integrating both sides with respect to, or you can do this way. Yeah, you can say with respect to x. So you're going to get d over dx of e to the 5x times y. Maybe you can do this. You know, now you can separate x and y. Yeah, let's do this way. I think this will make things more clear. Okay. Now integration and derivative, what happens? Antiderivative and derivative, you simply get e to the 5x times y on the left hand side. On the right hand side, what do you get? You know the integration of that, which is e to the 7x over 7 plus c. Now our goal is to find the value of y. So therefore y equals, you divide both sides by e to the 5x, okay? Divide both sides by e to the 5x. So you're gonna get y equals e to the 7x over 7 e to the 5x plus c over e to the 5x. And so it looks a little ugly. We are almost done. So when you simplify that, you're going to get e to the 2x over 7 plus, you can write this c over e to the 5x, or you can simply write c e raised to power negative 5x if you like. So this is your general solution. Any question? Okay, now if you don't have any question, then let's try one more. Maybe we'll do part C together, or part, this one is D. Okay, I will do part C or D, one of these two. Let me know which one you want me to do, and the remaining you have to do, okay? Okay, part D. So let's try part D then, that's okay. Let me just copy. I'm gonna, just give me 1 second. I'm gonna push this there because I need that space. Okay, there we go. So let's try part D. So the given question is, given x dy over dx plus 3x plus 1 y equals e raised to power minus 3x. So going back to the steps, step 1, first of all, you need to make sure that this is in the standard form. Okay, put the equation in the linear form. The standard linear form is, remember, dy over dx plus py equals q form. Now notice that here the coefficient is 1, but here there is x. It's not in the standard form, okay? Which is not in the standard form. So first, to change the equation into standard form, dy over dx plus p of xy equals q. Divide both sides by x. If you divide both sides by x, you're going to get dy over dx plus 3x plus 1 y over x equals e minus e raised to power negative 3x over x. That's what you get. Okay. Now notice that this on the left hand side, now this is in the standard form. The coefficient here is 1. Okay. Now compare this with dy over dx plus p. Okay, I'll write that x there. Hold a second. So py equals q in that form. All we need to know is what is your p. Okay, p of x is actually 3x over x plus, this is your p, right? P of x is 3x plus 1 divided by x. Or you can write 3 plus 1 over x. You can write this way too. So you need to find therefore, integrating factor will be e raised to power p dx. That's the formula, which means e raised to power p is 3 plus 1 over x dx. So that's going to give me e raised to power 3x plus ln x, right? This looks really interesting, isn't it? Now you can do a little bit of a high school part algebra and then simplify a little bit further. And what do you get? You can write this as e to the 3x times e to the ln x, which can be written as e to the ln x is simply x e to the 3x. Okay, so that is your integrating factor. Okay, we got the integrating factor. Step 2 is done. Step 3, multiply each side by integrating factor. Multiply both sides by integrating factor, which is x e to the 3x. Okay, so that what you get here is x e to the 3x multiply equation 1, let's say. Multiply equation 1 both side by integrating factor. So you're going to get x e to the 3x dy over dx plus x e to the 3x and 3x plus 1 over x y equals x e to the 3x times e to the negative 3x over x. Okay, I multiply both sides by the integrating factor. Now, the left hand side, the whole thing can be written as d over dx. Remember, what is there in the step? Once you multiply both sides by integrating factor, replace the sum of the terms on the left with derivative of I of x and y, that is d over dx of integrating factor times y. It always works. So integrating factor which is x e to the 3x times y. It always works that way. Equals, now this x and x cancel out, so you're going to get e raised to power 0, which is 1. Okay, which is 1. So if you don't trust me, then I suggest you find the derivative of, okay, just for fun, you can do that later. And just for fun, you find the derivative of x e to the 3x times y. Okay, find the derivative, and my claim is that you will be getting this expression as the derivative of that term. Okay, do this just for fun later. And now our job is to find the value of, y here. So what we need to do is integrate both sides, integrating both sides with respect to x. You're gonna get d over dx of x e raised to power 3x times y dx equals integration 1 dx. So dx cancel out, and notice that the derivative and antiderivative is just left with x times e to the 3x times y equals x plus c. So your y is going to be x over, you divide both sides by this, so y over x e to the 3x plus c over x e to the 3x. So that is your answer. It looks a little ugly. Maybe you can do one step further here. So y equals, this x cancel out, so you're going to get e raised to power negative 3x plus c over x e raised to power negative 3x. So this is your general solution. Any question, guys, so far? This question is not easy. There is a chance that people will mess up in the high school part, the calculation of this, simplification of this expression, logarithm and exponential function. Okay, so this one is the high school part. People may messed up in this part. Pay attention, recall the high school algebra, and other than that, you just follow those 5 or 6 steps, then you should be able to do it. Any question? So in example 2, solve the differential equation subject to the given initial condition. So let me just copy the differential equation, which is x dy over dx plus 2y equals 3, and the condition is given y of 2 equals 7 over 2. Notice that when we are given the initial value condition, we will be able to find the value of the constant. So that means we'll be able to find the particular solution. So basically in this question, you are supposed to find the general as well as particular solution. So first, is this in the standard form? What do you think? If not, then how can we change it into standard form? Okay, thank you everyone. Thank you. You replied in the chat box. That's great. So this is not in a standard form. In order to change into standard form, we divide both sides by x. Okay. Divide both sides by x to change into standard form, so that you'll get dy over dx plus 2 over xy equals 3 over x. Okay. So when you compare this with dy over dx plus py equals q, then you notice that your p is, the p value is 2 over x. So your integrating factor is going to be e raised to power p dx, which is e to the p is 2 over x dx. So that's going to give me e 2 ln x, which can be written as e ln x square. Remember the formula, okay? E ln x square, which means you can write x square. This is the high school part. So integrating factor is I square. Sorry, x square. So multiply both sides by integrating factor, which is x square. So you're gonna get x square dy over dx plus x square 2 over xy equals x square 3 over x. And so the left hand side can be written as, you already know, it always works like this, d over dx, x squared times y, the integrating factor times y equals x squared. Okay, this is going to be 3x only. Now integrate both sides with respect to x, so you're going to get d over dx, x squared times y dx equals 3x dx. So here, derivative and antiderivative, you simply get x squared y equals, this is going to be 3x squared over 2 plus c. So your y is 3x squared over 2 x squared plus c over x squared. And so your answer is y equals 3 over 2 plus c over x squared. So this is your general solutions, okay? General solution. Now, let me write this. General solution. Now, to find the particular solution, the condition is given. Remember, the condition is given initial value condition, which is y of 2 equals 7 over 2. So substitute that value. So y is 7 over 2 equals 3 over 2 plus c over x means 2. When x is 2, your y value is 7 over 2. So that's what you're going to get. Now simplify this. I trust that everybody know how to find the value of c, how to solve this for c, and you should be getting c equals, I believe, is it 8? 8. Now substitute the value of c back. Substituting value of c back in 1, c in equation 1, so we get y equals 3 over 2 plus 8 over x square, which is your particular solutions, okay? Particular solution. Okay, so we are done with this section, linear differential, linear first order differential equation. And you learn how to find the integrating factor and then, you know, solve the equation. If you have any question, let me know. Otherwise, this much for this section, and in our next section we will be we will apply this skill of solving differential equation to solve real world problems, okay, particularly from business and economics.